Hello again. This video goes along with 2.2, which is on solving graphically using technology. We're going to show you the graphing calculator and Desmos again, depending on what you have available at home. So here's the first problem that we're going to do. Find where f of x equals 850 times 0.72 to the x reaches a height of 500. Okay. The key word that you should be zooming in on is height. Okay. Height is the vertical direction, or in other words, they're giving you an output value. So now you know that the 500 is an output. It is a y value. Okay. So if I want to know where this function reaches a height of 500, I'm going to want to make a boundary at that height, okay, when I make the graph. Before we turn to technology, what do you know about this function? Okay, don't wait for the calculator and just trust the calculator. What are you anticipating you're going to see? I'm anticipating an exponential graph because it's a b to the x. I'm anticipating that it's going to be decay because the factor is 0.72. And I'm anticipating that the y-intercept is going to be 0, 850. So with that knowledge, I'm going to have to set an appropriate window. So now let's turn to some technology. So we go into our calculator. We go into y equals. We clear out what we had there, and we're going to type 850 parentheses 0.72 raised to the x. Okay? And remember, your variable button is this xt theta n. Okay? But not only do I want to graph that, I also want to know when a y value of 500 comes up. So in y2, I'm going to put that other y value. I want to see where the boundary is going to hit 500. Now I have to think about my window. So I'm going to go to window. Obviously, this window is going to be way too small. Okay? Let's set my x's from -10 to 10. Okay? Just to give us a range around 0. And let's change it by 1s. My y min doesn't have to be negative, because what did we learn about an exponential? An exponential does not go below the x-axis. So I can start my y min at 0. What do I know I need to get up to? Well, it's going up to 850 and then it's decaying, okay? But I do have to see 850. So I'm going to make my y max maybe a little higher just so I can see the point. So maybe 900, and I'm going to count by 50s. Okay, that part is up to you as long as you can see what you need to see. And now, based on my knowledge, I'm going to hit graph and see how it works. So there's the window. Here comes the graph. So it turns out there's a lot of empty space over here. I really didn't need to go from -10. So maybe I go back into my window, and instead of going all the way out to -10, maybe I start it at 0 and then look at my graph again. So I'm seeing a very nice exponential. And then this line being drawn is that 500, okay? That's where it's giving me that height of 500. So I'm interested in that point right there. I want to know when this function hits 500. I need to get my calculator to tell me that point. So we're going to go to second trace. So not just trace, second trace. And the blue writing there says calc. This is our calculate menu. We're going to use really the top 5 things in this course. Okay, those are going to be the most helpful for us. So I want to know where they intersect. I'm going to choose number 5. And then it asks me first curve, question mark. And I can bring my cursor using left and right arrows as close as I can to the point of intersection and hit enter. It asked me second curve, but notice it didn't really move much. It just went to the second function. So I could just hit enter as long as it didn't move. And then it asked me for a guess, but again, it didn't really move. So I can just hit enter. You are not completely finished until you see the word intersection here. So the intersection is at 1.615, comma 500. That's the point that these two cross. I already knew that it was 500 though. So I don't care about this part of the ordered pair. I care about the x part of the ordered pair. So this occurs when x is approximately 1.6153 if I round up. Okay? Now, this is how you do the calculator. Now let's look at Desmos. So go to the graphing calculator in Desmos. Okay, and we're going to type in y equals 850 parentheses 0.72 close parentheses raised, which again is the caret, to the x. Okay. Now, notice that nothing was drawn, and that's the same issue, okay? It's about setting your window. But the cool thing about Desmos is you can explore to find it, okay? So you can find what you're looking for. This still shouldn't be a substitute for you knowing what you're looking for, okay? I know that this is going to hit the y-axis at over 800, okay? If I want to change my scale to be able to see that here, then absolutely you could change your scale. Okay, because right now it's changing the scale in proportion. I might not want to do that. Okay, I might want to make this go way higher. If you want to do that, you go to the wrench. Okay, change your y-axis to go from 0 to 900. And maybe count by 50s, okay? That's what we had done in the graphing calculator. So now you can see, okay, that it changed the scale. You can do the same thing for x if you want to see the x's, okay? So remember that you have the option of setting whatever you want. In the second spot in Desmos, you're going to put y equals 500. Okay, all this is very similar to the graphing calculator. Notice how it automatically graphs. But now here's the cool part of Desmos. That intersection point is going to be one of the important points. It already knows you're going to want it, so it gives you that point without you having to tell it anything. Okay, so I know that it's going to be 1.615. Okay, and that's the same thing that we got using the graphing calculator. Okay, so that's using Desmos. All right, let's do the same function back to the graphing calculator, but this time I want, and this is just reminiscent from the last video, or one of the last videos. I want to find f of 10. Okay, what does this mean? This 10 is inside the function. So this is going to be an input, okay? I want to know when x is 10. I can do one of two things. I could physically plug in 10, okay? And I could do the work. Or because I already have that function in here, I could just press trace, regular trace, and I could type in 10 and it'll tell me what that output is, Okay, so I did discuss this in one of the last videos. Okay. All right. The next one that we're going to take a look at is how to find a minimum and a maximum point. So here's our next one. We want to graphically find the vertex of f of x equals x squared minus 6x plus 10. First, let's just take a look at this and know what it tells us. Okay, again, going back to previous videos. The a value here is a 1. Okay, a is 1, b is -6, and c is 10. My a value being +1 means I'm going to have an open up parabola. Okay, this is going to open upward. And I know that the y-intercept should be 0, 10. All right, I should anticipate this, all right, and not just rely on the graphing calculator. Now I'm going to use my graphing calculator to plot that. So clear out what we had from the last problem, and I'm going to type in x squared minus 6x plus 10. I'm going to want to set an appropriate window here, okay? I know my y-intercept is 0, 10. I know this is going to open upward. So you can start maybe in what's called a standard window. A standard window is from -10 to 10 with an increment of 1 on both axes. There's also a quick way to reset that. You could just go to Zoom and choose number 6, and it will automatically graph in a standard window. Okay, sometimes this is a good starting point when the numbers are relatively small. So we can see that we really didn't need any of these negative quadrants. Okay, so I can go back into my window and I can lower this. Maybe I make that -2. Maybe I make this 0. Okay, and then look back at the graph. All right, that looks really nice. Okay, I'm interested in finding the vertex, which in this case is a minimum. And again, why should you anticipate that? If it's open up, that means it's going to have a minimum. Okay, so open up means it has a minimum, has a valley. Well, you might remember that that trusty calc menu, so second trace, had a choice for minimum. So we're going to choose number 3, and then we're going to follow the prompts. The first prompt says left bound ? Bring your cursor anywhere to the left of the valley. It doesn't matter where, okay? Anywhere to the left of the valley, and hit enter. Then it switches the question and asks you to move to the right. Make sure you're passing through the valley so that you can get to the right. Doesn't matter where, hit enter. Then it asks for a guess. Get close to the minimum and hit enter. You're not done until it actually says the word minimum, and the minimum here is the 0.31. Okay, so now I know my vertex. My vertex, based on my calculator, is the 0.31. Okay, let's do one more quadratic. Graphically find the vertex of f of x equals -3x squared plus 15x plus 42. Before you jump to your calculator, ask yourself what you know about this function. A is -3, B is 15, and C is 42. This tells me that it must open down, which means I have a maximum okay? And this means that the y-intercept is the point 042. This is going to help me when deciding my window. So now, with this information, I'm going to go back to our calculator. In y equals, I'm going to clear out what we have there, and I'm going to type in negative 3x squared plus 15x plus 42. Okay, I need to go to window so I can set an appropriate window. All right, maybe I'll switch back from negative 10 to 10 for my x's. But for my y's, I know I'm going to want to see 42, okay, at the very least. So maybe I'm going to go from, I don't know, negative 10 to 50. And maybe I'll count by tens. Let's see how this looks. So let's go to graph. Okay. Not too bad, but I'm not seeing my vertex yet, okay? So I do have to adjust my window, go a little bit higher than what I originally had. So let's go back into window, and I'm gonna change my Y max to be 80, okay? And then go back to the graph. Here comes the face down parabola. And now I can see the vertex. So I'm seeing all the important features. I want the vertex especially. So to find that point, I'm going to go to second trace. I'm going to choose maximum this time because it's a peak. So number 4. Same prompts. Go anywhere to the left of the peak. Hit enter. Then make sure you go over the peak, somewhere to the right. Hit enter, and then get as close to the peak as you think for a guess, and hit enter. And again, you're not done until you see the word maximum, okay? And then you'll know what the maximum is. Now, here's a word of warning. Your calculator does have built-in error in it, okay? It's not perfect. It's using approximation techniques to get really, really close, most of the time exactly at the right answer. But here's a situation where it's got 2.5000007. That 0.00007, that's the error because that is so tiny. That is so tiny. It's pretty much just 2.5. If you're trying to do this at home, you're following along at home, which I'm hoping that you're doing as you're watching this video, your calculator might have given you a 2.499999 something, okay? Those nines, again, don't mean that that's the answer. They're so close to 2.5, okay? So you're gonna, again, be smart, okay? You are smart, okay? Your calculator is not smart. Understand that this is just the calculator's error, and you're going to write the answer as 2.5, 60.75. Okay, please, I don't want anybody to tell me that the 0.00007 is part of that value. Okay. All right. Let's switch over to Desmos real quick, just so you can see what a parabola will look like. Okay, I'm just gonna delete that one. All right, I don't know why this comes out fuzzy sometimes and not other times, but we're gonna type in y equals, let's just do the last function we had. So negative 3x squared. Let's see, negative 3x squared plus 15x plus 42. Okay, oops. I'm not getting pluses. 15x. There we go. Okay. Remember that because this is a little bit more interactive, I can find my parabola okay? And now watch this. If I touch it, these key features automatically show up, okay? Do you see little gray dots? If I actually touch one, that value is gonna come up. So I got 2.5, comma 60.75, exactly what we said, okay? So I can easily find the vertex for my parabola. Okay. Last but not least, for the graphing calculator, we're going to see what happens if we want to solve an equation. So if you have any equation that you're being asked to solve, for example, let's say we want to solve 2/3 times x minus 7 plus 9 equals x squared, okay? We should anticipate what we're seeing here. This side is a linear. This is point slope form, m times x minus x1 plus y1. This side is a quadratic because the high power is a 2. Okay? I should anticipate seeing a line and then seeing a quadratic. So what we're going to do is we're going to put the left side in y1, and we're going to put the right side in y2. Okay, that's what we're going to be doing here. Or if you're using Desmos, one would go in the first spot and the other one would go in the second spot. So clear what we have there. We're going to put 2/3. I like putting my fractions in parentheses. I mentioned that in a previous video. Times x minus 7 plus 9. Okay. And then in my y2, I'm going to put x squared. Okay. These numbers are relatively low, so I'm going to start in a standard window. That means I can just go to zoom 6 to get back to a standard window. Here comes my line. Here comes my y1. And here comes my x squared, my quadratic. There are going to be two answers to this because they happen to cross each other twice, okay? So I'm going to have to do my intersection 2 times. So we're going to go to second trace. We're going to choose number 5, and we're going to follow the prompts for this first point of intersection. Just hit enter 3 times, and I get my first answer. So this is going to be when x is approximately negative 1.774, okay, 85. And then I have to do the whole thing again. Second trace, number 5, except this time I'm going to go to the other point of intersection, hit enter 3 times, and I get that x is approximately 2.4415. Okay? Now, if it's fine using decimals, then you just leave this as decimals. The reason why we're not writing this as an ordered pair answer is because it said solve. We weren't solving for a y here. We're being asked to solve for x here. So I only care about x values, okay? These are the x values that are going to satisfy this equation, okay? So always pay attention to what they're actually asking for whether you need to have a full ordered pair or to just give an x equals, okay? Now, let's say you want to see if these can be written as fractions, okay? Can they be written in fraction form? The last x that you have in here that you made the calculator find is already in the calculator's memory. So what you're going to do is you're going to go back to a clear screen, which is second mode, okay? It will quit, it'll go to a clear screen. You're going to press the X button and you're going to hit enter. See, the last X that we found comes up. If I want to know if this can be written as a fraction, I'm going to go to math, frac, and it can't. okay? It didn't do it, which means it can't be written as a fraction, right? But your calculator does have that x value stored. Keep in mind, it's only the very last x value that you made it find, okay? So you're gonna have to do it for each one if you wanted to make sure what it was as a fraction, okay? But you do have that ability to use the stored value in the calculator, okay? In Desmos, when you put this in Y1, okay, or in the first spot and this in the second spot, remember that it's just going to graph them automatically anyway. You can find the graphs, and then it will automatically show you those intersection points, right? And all you got to do is touch on them, okay, with your mouse. All right, so I hope this made sense. All right, it's a little course in the graphing calculator or Desmos. And if you have any questions, please let me know. I will see you in the next video.